Alright, so starting things off, I just went to Google and did a quick nebula search. And we're just going to poke around in here and get a little bit of inspiration for the kinds of things we're going to make in this tutorial. And basically you can see that there's a ton of really sweet looking stuff out there that is actually quite easy to be able to create in Houdini. So I look at stuff like this and I see a lot of pyro, I see a lot of particles, things that we're going to be able to really easily achieve using Houdini to get us these kinds of visuals and these kinds of formations. So some really cool stuff. And you'll see also that the majority of what makes these things so interesting is just the different colors and the light play, how things are thin and voluminous, but then also you get these denser packed regions of density inside. And it's really these kinds of shapes we'll find as we go through the tutorial. They're very simple, very easy to achieve, but it's really all about the art direction and just layering upon layering and layering of stuff. I mean, there are things like this that are a little bit more simplified, a little easier to make, like shapes like this. This is not that complicated. But it would be really cool to do things a little bit more like this, just really spectacular visuals, really interesting formations. So there's going to be a lot of great reference and inspiration just with a quick Google search. So let's go ahead and get into it, but I just wanted to look at this real quick. I would say I always start every project with reference, just something to give me a little bit of inspiration. Gosh, these images are beautiful. It's going to be so fun making some of this stuff. So let's go ahead and hop over into Houdini and get things started. Alright, so here we are in Houdini. Currently we're working on version 18. The newest, the latest, the greatest, but then 2 years from now it would be like 18. The good thing about Houdini is, I mean, really it doesn't, most of what we're going to be learning is not going to be something that's tied to a specific version of Houdini. It's really just dynamics in general. So a lot of these concepts will be able to just move forward with you through the years because it's just dynamics. It's not specific to this node or that node kind of a thing. So first things first, we can start off, and is what's going to be really fun about this course, is we're going to start off with just a cube. And the majority of all the awesome things we're going to make are going to start from something as simple as just a cube. Now, you might say, how am I going to turn this into a galaxy? But you're going to find it's very easy. So the first thing we want to do is let's call this nebula base. And let's change the color of that. I just like to keep geos and things like that as a blue. My emitters I usually make red, things like that. Personal preference, do what you like. So the first thing we're going to do with this guy, as we hop down in, is we're going to use something called VDB from polygons. And now what this is going to do, you can use this node, or really what I use this node for a lot is converting objects or models that I get for specific projects for collisions and things of that nature. A lot of times the volume collisions are going to be the strongest collisions to use in Houdini, give you less problems and less errors. Sometimes surface is enough for collisions, but really volume collisions are the way you want to go. And a lot of times the models you get are just not watertight, things like that. So the best way to do that is you want to convert them to a VDB. And so then you get something like this, where you can increase the resolution by decreasing the voxel size. So you can get something closer to what it originally was. But that's VDB from polygons. But we're not going to use it for collisions right now. We're not interested in using this distance VDB, giving it a surface. We want to turn this to a volume. So now we've got this fog VDB. And this is where we're going to want to be. Okay. So now that we have this fog, we can use things like a volume VOP to get us some interesting shapes out of this square. And so that's going to be the second step to this preliminary process. Okay, so now we want to throw down a volume VOP. And then also, just go ahead and throw a volume visualization, just so we can see what we're doing a little bit better. We'll use density, and I want to pump that density up. Now we're going to be doing things in a wrangle later on where we're going to increase the density of the volume, but for right now, to keep things lighter so that our machine doesn't get as bogged down, we can keep things light, but then use this volume visualization to just visually see what this thing would look like if we gave it a lot more density. And the reason I want to see that is because if I drill down into here, what we're going to do now is we're going to throw down a turbulent noise. And an add. Because we're going to use this noise essentially to cut out some interesting shapes into this volume, which we can then use for everything moving forward. So the first thing you want to do is take the position and transfer the position of our object into the noise so that the noise knows where in the world it is. Take that position as well and throw it into the first input of the add, because now we're going to take the output of this turbulence noise and add it to the position and then use that as the density. And so you see now it's cut out a chunk of our volume, and we'll go ahead and change from 1D noise to 3D noise. And there's a number of different noises to choose from, as always. Let's see what Perlin gives us. So we've got some interesting stuff going on there. I think I'm going to hop up a level, and let's give this guy a little bit more resolution. Give that a second to think. Okay, I actually took that voxel size to 0.08 instead of 0.001. So if we want to see a little bit more detail in here, see what we have going, I could hop up a level real quick, just throw down a light. Throw that light over here. All right, and so we can see now a little bit the kind of structure of what our noise is giving us. We can get some really interesting shapes this way just by playing with that noise. So let's pop back down in here. And really quick, let's just cycle through our available noises. Okay. All right, so let's just play with this Perlin noise to begin with. Okay, and you can see already we're kind of getting some really interesting formations. Like, you know, if you really zoomed in there, got in there, you're kind of already feeling very nebula-like. But now the first thing you might say is, you know, okay, well, what about these sharp corners and these sharp edges? Those are not going to be a problem for us a little bit further down the road. Right now, this is really just about getting these shapes, finding a shape that we like, that feels interesting. There we go. It's kind of neat. That's kind of cool. And then now something else we can do. Something else we can do in addition to just using these types of things for formations is you can also get different looks by just going straight out of the noise and skipping the add. So again, it's just really playing with this noise and getting us what we consider to be interesting shapes. Kind of a board cube thing going on there. All right, well, let's say that I just want to start out with this. Let's go up a level. Maybe let's make that box a little bit taller. Get us something interesting like that. I like kind of this little finger that's coming off on the side there. All right, let's say we want to just start out with this. Now the next step that we're going to do from there is we're going to want to take this volume that we've created and we're going to want to fill it with points. Okay? But now we're going to start getting into the land of memory usage, and things can get a little computationally expensive. So let's go ahead and just start saving our scene. So let's set the project. Okay, Nebula Volume 2 for me. Accept. Okay, let's just call this Nebula version 1. Alright, now we're safe, good to go. Okay, so now that we have this shape that we like, I want to use VDB from polygons one more time, because this convert VDB, we changed it from a volume back to polygons so that we could see that shape. But now let's take that, turn that back into a volume. Try to preserve as much of the detail as we can. So I'm going to have to go down a little bit smaller. Very good. Looks close enough. All right. And so now, same as before, we don't want to be a surface. We want to be a volume. So now we've got our cool shape. Let's go ahead and do a points from volume, because what we want to do now is we want to scatter points into this volume that we've created. But for this particular task, we don't want to use the actual scatter node. This points from volume actually scatters points within a volume much faster than the scatter node does. The scatter node is going to be great for us for making our star fields and things like that. And you can do this exact same thing, you know, filling this volume with a scatter node. But I'm just telling you, computationally, it takes much longer than this points from volume. So that's why I always go to this one instead. But so now you can see that we filled our volume, but we have all this sort of banding that you can see because the particles are evenly, perfectly, geometrically laid out. So what we're going to want to do is introduce some jitter. And now we're randomized. Okay. And now the thing with this is down the road, we're going to want to get a lot of particles. Right now, we're only at about 500,000 particles. And the one drawback of the points from volume as opposed to the scatter node is the scatter node, you can tell it exactly, I want this number of particles. With points from volume, you have to kind of work at it using the point separation and then just keeping an eye on the number of points that are generated once that completes by just middle mouse button clicking on the points from volume, and from there we can see how many points we've actually generated. Now we can middle mouse button and see that we have 500 million particles. So we can probably get there when we're going for our final version of these objects, but for right now, just for our working, this is way too many particles. Your machine may explode. So that's why, again, that's the one drawback of this one, where the scatter node, I could tell it I want exactly 50 million particles rather than 500 million particles. So just keep that in mind. There's a little bit of back and forth with that. So let's take this up a bit and reduce that particle count, because we don't need that many particles for right now while we're deving. So right now about 2 million. Let's see, just give me a little bit more. 7 mil. And 60 million. Okay, so let's just say, ayo! Like I said, it's a good thing we saved. All right, let me refresh this, and we'll knock that particle count down just a little bit. Okay, so open back up again after the crash. I'm gonna leave that stuff kind of in there because it's interesting to see. I mean, it happens to everybody, and you need to see what it does. So I'm not one of those guys that deletes everything out of the tutorial and makes it look like it all just happens easy peasy. It's Houdini, man. Sometimes it crashes, sometimes you lose your stuff, you gotta do it again. So let's go ahead and just do some of that again. So to get back to where we were, we want VDB from particles, or not particles, sorry. We want our VDB from polygons. Where'd you go? There you are. All right. So let's get back to where we were. I think we settled on 002. And then we want fog density. And then we want points from volume. Again, it's always super easy to do everything the second time. So much faster. All right, so I think we want, let's try 0035. All right, there we go. How many points do we have now? Middle mouse button, click, 11 million. Okay, let's just, for sake of argument, we'll just play with this and consider this like an LOD, like a medium level of detail. You can see that without the jitter, we've got the ray of sunlight, the North Star. Let's go ahead and jitter that out of there. So now that we have all these points, let's go ahead and hit D, open up our display options. Don't want to view them as points. I want to view them as, come on. Locked up there, hold on. Let's try that again. D. There we go. Yeesh. Alright, so let's look at these pixels. And now we're going to start introducing our noise that's going to give us some shape that kills these sharp edges. gives us something interesting. All right, so under that points from volume, let's throw down a point VOP. And before we move forward, let's go ahead and save again. Save and save often, my friends. Any dynamics artist will tell you. Okay, so now inside this point VOP, we have a number of options for noise. So you've seen before we've used turbulent noise, which we can use again here. Go ahead and use our add, points in, position, and out. All right, and now you can see that we're already starting to get some influence from that noise. Now we want to, of course, use 3D noise so that it's not just a smear. There we go. Now you can see that we've eliminated those harsh edges. Let me go ahead and let's promote all these parameters. Come on. My machine is just being funny today. And lastly, turbulence. Okay, so now we can leave this area, get us back up a level. Whoops, one too many. And now we can do all of our changes onto the point VOP itself. But the reason I want to come back up to this level is because I wanted to show you again. If we turn this off, you can see there's our funky square. Let's throw a little bit of noise on it. And now we've got a pretty nebular looking shape. So that can be cool. Then now let's play around with this noise. Again, if we cycle through the different types of noise, it'll give us different shapes, different options. Let's try Perlin. That'll give us something that's a little bit closer to what our original was. Got this nice little finger coming off here to the side. Really like that. Let's see, sparse convolution. It's okay. Gets a little smeary, a little streaky in here. You can see there. So not 100% in love with sparse convolution. Alligator gets us something that's a little bit more tightly packed, which can be cool. And simplex, again, you know, just cycle through, find the ones that speak to you. You get a lot of neat shapes. I think I'm going to stick with this one though. Alright, so let's call this point VOP. We use turb noise. So we'll call it turb noise, alligator, point VOP. And the reason I'm going to do that is because I'm going to show you a bunch of different noises because they can all give you different kind of aspects of formation and things like that. And we're really, it's the variety and the layering of these things that's going to get us that really sweet, sweet look. All right, so now that we have that one, let's just be cheap, Alt-click, make a duplicate of that. But then now in this one, instead of a turbulent noise, I'm going to use this anti-aliased flow noise. Now this one I really go to a lot when I'm doing these sorts of nebulas and spatial anomaly kind of shapes. This gets a really nice sort of flowy, streaky, it'll give you a lot of really nice formations. So we'll do the same thing. Position in, noise out. Now we'll go 3D, 3D. Okay. Alright, so here we've got our flow noise rather than the turbulent noise. And see if I turn that off, go back to our original shape, square it off, all that good stuff. Turn that flow noise back on. And what you're going to find with this flow noise that's different than just the regular turbulent noise is you're going to start to get all these sorts of swirls and veins running through, giving us just a lot of nice interior detail. So we can see that right away if I just increase the amplitude a bit. And you can see now, got sort of these swirls inside of swirls inside of swirls. And now we can add a little bit of flow. And that flow is going to empower this advection. So just a little bit of advection, self-advection. A little bit goes a long way. So there we go now. So now that kind of sucks everything in and just has it sort of flowing in itself, giving us those nice little sort of veins of flow. Okay. And now as we go in, you can see that those little things are going to be inside there. And then in here in this core, it's all sort of flowing in and out, as opposed to just being sort of a noise. So this, and the reason why I said that I used the flow noise more than anything else, is this one will really give it a sense that it has a purpose. That, like, you know, it was created somehow, and it's all connected, it's all working within itself, it's flowing together in a more organic, interesting way, which is just perfect for these sorts of spatial anomalies. Okay, and now again, you know, you could just do this to taste, go as far as you want, but you'll see a little goes a long way. Watch this one here, give it a second to think. Yeah, so that really starts to come together. See that accumulation on top of accumulation just flowing. Okay. So let's see one more time. So we had 4. Let's go back to that 2. I think for this particular piece, I'm going to stick to 2. And then I'm going to talk really quick about something we're going to be doing here in just a second, and that's a technique that I use in this sort of process is I'll sort of bracket these shapes because that's going to help us later on in terms of the density when we're actually doing look dev and shading. And so what I mean by that is I'll take, let's say, this specific shape, and then I'll do one point cloud that has these settings, and then I'll go back to that VDB from Polygon that we had, and I'll use an ISO offset to kind of choke it in on itself so that it will have this same profile, but just instead of the edge being out here, it'll be more sucked in. And then you do 2 or 3 of those, and you really get a shape that has interior complexity. And then you give each of those shapes their own shader and their own look dev, and they just really start to accumulate on each other and work together in a way that catches light in an interesting way, and it makes everything that much more effective. And so now what we would do, say for instance on another version of this one, is if I take this roughness down, that's going to, kind of poof it out a little bit. It has less of those very defined, strong veins. But what can be cool about that is that if we have this sort of more diffuse, we'll just call it diffuse shape, and then you have that tighter, more complex shape inside of this shape, then it really, like, again, it just accumulates on itself and gets you in more interesting shapes and looks. So let's just say that we're going to stick with this one. And then now you can see the different sort of looks that you get. So here's our, well, actually, let's change this. This is our AA flow. Flow noise point bob. And then head over back to our turbulent one, and you see just a large variation difference from one noise to the next. And now for me personally, I find the flow noise to be just a more complex, interesting shape that's created. So you can, do what you like, but I just wanted to show you a difference in just two different noises, how it can give you a vastly different look. And now you can see here on this one, if you come in, there's a little bit less internal complexity. It's a little bit more just sort of diffuse and more of just a volume, whereas the flow noise really has some interesting shapes, and it looks like it has a purpose and a reason. So moving forward for me in this tutorial, I'm going to be sticking to the AA flow noise, but there's a number of noises that you can choose from and go to town. They're all going to give you interesting looks. So I just wanted to show you that so you can see different noises will get you different looks. Now, moving forward, let's go ahead and I'm going to delete that one. Let's pack everybody here together. And then I want to collect this because I'm going to start duping and making alts. And I want to keep things a little bit more coherent. So let's just call this nebula base. Give that a different color because gray is boring. And so this right here is going to be one of our shapes. So what we want to do now is go ahead and let's cache this out. We're going to be doing a lot of caching and packing throughout this tutorial. It's just going to make things a little bit easier on your computer because these things can start to, again, accumulate and start hitting your RAM. So let's start caching and packing. But the thing that you have to keep in mind is once you've packed something, it's going to pack it in the state that it is. So let's say if we packed it one level up at just the points for volume, it's going to pack out this shape. And then we wouldn't be able to throw this point fop onto it to displace that shape. It is going to be locked in. Once you pack something, it's going to be locked into that shape. Now there are some things you can do to modify, but just keeping everything super clean. Just remember to cache and pack at the end of your chain. Once you've got a look and a shape that you're happy with, that you don't think you're going to come back and mess with that much. So let's go ahead and do that now. So let's just throw down a file cache. Whoops. File cache. And let's call this nebula base. And what's great about this scenario is we don't need to save a range. All this is being done on individual frames, so that's going to keep your footprint on your disk much smaller because you're not simming out huge simulations, which we'll get into a little bit of that later in a different variety when we're going to use some particle fluids and things like that just to give us different interesting shapes. But for this particular technique, it's super cost effective. You're just going to be cashing out one frame. And so now this is where we'll go up the chain, and we're going to want to add more points because I want to have more density than just what this 11 million particles can get us. So take that down to 2.0002. And then we were at around 11 million particles. We're looking at, we want to be somewhere in the range of 100 to 200 million particles for the things that we're going to be doing. So let's just give that a moment to calculate, and I will be right back. Okay, so 0.002 took us to about 62 million points. I want to go a little bit lower than that. Let's say 125. All right, now we're talking. That got us to 257 points, 257 million points. That might be more than we need, but, you know, it's going to be pretty. So, okay, so we're going to call that the base. Go ahead and let's just save that out to disk. Okay, now that that's saved out, verify, going back to load to disk, give that a second to think. Beautiful, okay, and so now here you can see that we've got all of our shape and everything inherited from what we have done before. And then you come in tight and inside, and you can see that there's all kinds of stuff going on inside there. So we'll have good stuff to work with moving forward. So now let's start talking about those different alts and variations off of this particular shape. So let's go back to the points from volume, and let's knock that down a bit. Okay, and then let's go back up the chain. All right, so come back to this convert VDB, and then let's just eat away at it a bit so that we get something tighter. Don't need to do that. Okay. And so then we come back down the chain. You can see that that's thinner now. And actually, if we want a good representation of that, let's take that back to 0. And you can see that we choked it in a bit. So let's do that again. Choke the values in a bit. Not that much. We still want a little bit of this. Okay. So then now, back to our points from volume and our flow noise. Going to get us another shape that then will be in the interior of the last one that we had. And we can make this, when we get back to the actual shading and the rendering look of all this, we can make this much more dense, and the last one we had a little bit more thin and wispy, and they'll just, they'll accumulate on each other and be really, really cool. But if we want to be clean. Let's undo all of that. Put everything back to where it was. And then let's just take this whole thing, duplicate it so that we work non-destructively. And then let's do that here. So that -0.1, choke that back, points from volume, flow noise, and if we hop back and forth and switch between the two, you can see that it'll be the same shape, same profile, just this one's been eroded in a bit more. Okay, and maybe just for fun, we can play a little bit with one of these values. Let's say a little bit more self-advection. Is that going to take us too far away from the shape? Maybe, maybe not. A little more roughness, perhaps? No, because we want to keep it tightly packed. So 0.45 versus 5. 0.4. I guess we'll just keep, whoops. 0.5. Increase the max octaves. Flow rate. Is this something interesting? Some slight variation. I kind of like that one. And then again, hop back and forth. Yeah, you can see it's still similar in shape, just slightly choked. Okay, and then let's do the same thing with this guy. And then we'll do O2. Give that a moment to cook. Alright, now we're back, and we've got about 50 million particles, points inside that. Let's do 1.5. Just want a little bit more than that. Alright, and now we're about 121 million points. Okay, let's say that's what I want. So let's throw down another file cache. Call this one Nebula Interior. And while I'm at it, go ahead and update this. Nebula Interior, and let's change the color. Save current frame, save to disk. Alright, now that's saved out. Verify real quick. Okay. All right. So let's say that we're good there. Now let's move on to the second phase. And that is rasterizing these particles. Volume rasterize from attributes. But before we do that, we need to throw down a wrangle. Point wrangle. Let's make a new container. Call that interior rasterize. All right, and now why is this point wrangle important? Well, first, let's go to the volume rasterize, activate it, and then you'll see nothing there. And the reason is it needs a density attribute, but we do not have a density attribute. So we have to create that. So in this point wrangle, and now in my point wrangle, I always have a macro that creates a p-scale attribute for me. But if you wanted to use this p-scale attribute for yourself, just type out this expression and then do say preset. And so then from now on, anytime you open a point wrangle, that will be in there. And I use this p-scale all the time. So that one is just at p-scale, randomized by ID with a min-max function. And then we can go ahead and just do 0.001, 0.003. We can do higher values, lower values, but again, still no density. Now what we have to do here is say at density equals 1. And then come up here to attributes, add density, give it a moment to think. All right, and there we have it. So now we have density. And we can decrease this voxel size on the rasterize so that we can see the detail that we have. And then now you can really start to see all that nice flow that we got from our flow noise. All right, and for now, we could take this voxel size down smaller, but at the moment, I want to try and keep things easy for us to navigate in the menu. But we can go back to this point wrangle and we can manipulate this density here and say, I don't know, how about 100? Boom. All right. Now we're getting somewhere. How's that looking? Super exciting. All right. So now, let's say, I don't know, maybe let's take this down just a little bit. 07. Cool. And then we start to get a lot more detail. You can start to see striations in that volume. Very, very cool. Let's take it down a little bit lower, just for example. Very cool. Very, very cool. And then let's take this density down a bit. Oops. There we go. Cool. Let's say, let me take that down to 5. Let's make this thing a little bit more sparse. There we go. So now you can see there's just a ton of really great detail in there. Light is going to scatter through there very nicely. Very nice. So let's just say, how about 20 for now. I always do that. I always hit enter and move the semicolon. Very cool. All right, so that's our interior volume. Now let's do this same thing. Cut that off. Drag this over here. Call this base. Rasterize. Give it a slightly different color as well, just because I always like things to be a little different. Alright, and then now let's pump this guy in there. But actually, you know what? Before we do that, let's save. I'm totally PTSD about crashes. Alright. Saved up. Okay, now we can move forward with Wild Abandon. Alright. Very cool, very dense. And now, for sake of argument, just throw down a color node. And let's say we make this pretty pink. Now you'll see that nothing happened. Well, why is that? Well, because again, you have to bring all those attributes forward. Okay, and you'll see we've got the density and the color value, but you'll say, well, you know, where's my color? Again, nothing's happening. Well, to visualize that, we need volume visualization. And then in the density, we want density. And in the diffuse field, we want to throw our CD. Boom! There's your color. All right. Play with that density a little. Okay, and then now, just for visualization's sake, let's do a merge. And view that. Okay, we merge that, nothing happened, and that's because the chain was broken. So reconnect it to the cache. Boom, there we go. And so there you can see, again, this is just in the viewport. This will be much more awe-inspiring in the shader. But you can see where we start to get that accumulation. We've got that interior mixing with standard base. Very cool. Very cool. That's going to start to look awesome down the road. Because you've got this diffuse shape with complexity internally. It's going to catch light really well. That's going to be a really cool, really interesting shape for us to use and work with. All right. So that's going to be really a big part of our workflow. The meat of the workflow is essentially this technique. What achieves this technique is you're going to take a volume, you're going to fill it with points, you're going to give those points an interesting shape using a point VOP, then you're going to rasterize those particles. So now that we have a shape that we're pretty happy with, let's move on and look at some different techniques that we can get some really interesting shapes out of using particle fluid.